All right, I'm going to do the in-between question. So 93 and 95, this one's going to be super symmetrical because it's 94 in the middle. 93 and 95 are half a standard deviation left and right. So not quite at the inflection points. So 93 here, 95 here. Doing a between, so I'm shading this. So the z-score for 93 is going to be minus a half. The z-score for the 95 is going to be positive a half. I'm going to look those both up. By the way, the calculator is not going to give me these steps. It's not going to give me the z-score or the two numbers you're looking up, but I still need to see it on your paper, so, well, figure out how to do all that. But it is a great backup to double check if this is going right or not. So that's what I would recommend it for. This one says 0.3085. Positives on the other side, 0.5. 6915. These are related in a cool way. I'm going to ask you about that sometime. Now I need to subtract these. Either way, I should have put the higher z-score one first. All right, so to make this come together, I'm going to label the z-scores. Negative a half, half. That's a 0. This area on the left that I don't want is 0.3085. I could put 3085 on this side too. It's symmetrical. I do want to find a home for the... Wait, how did I get a 9615? The heck was I doing? That ain't right. Okay. Positive 0.5. 6915. There you go. Okay, that makes more sense. Now, 6915. And then when I subtract those, I'll get something different. Okay. I have shaded 38% of my graph. That seems much more plausible. All right, so calculator check for me. Thank you. Go to vars, second vars distribution, normal CDF. So I'm going to between now. So this is where my lower upper bounds don't have to be weird infinity substitutions, right? So I'm starting at 93. I'm going to 95. My mean is 94. Summation is 2. This is where this really pays off, right? Hey, I got my answer. Oh. 383 if I round this, right? And so then that's a really fast one. And if this is a multiple choice question, I would probably do it this way. I might sketch it just to make sure my numbers are right and that I understand it. But this will be a way to really speed up a multiple choice question. So I would say 38% of fastballs are between 93 and 95. All right. The other thing I want to mention, folks, is up here, it says on the AP exam, you can use calculator notation, but only if you're insanely careful. So here's the deal. Having graded these before, the grading sheets change from year to year, but you need to identify that it's a normal curve. Somehow. So just using calculator notation is not sufficient. So for example, using Z, that is sufficient for that's a normal curve. All right. The other option is to use the N notation. So if I said N94.2 and you were in this problem, that would cover it. That's normal. You need to identify the mean and the standard deviation. So if you use this notation, that covers both of those points, which is nice. If you're doing the graphing, just make sure you put the standard deviation on somewhere and that the mean is on somewhere. And then the Z is what's going to give you the shape, right? And then the other thing you have to mention in these problems, if you're doing that the fast way and trying to like really quickly fill it in backwards, is you have to talk about the boundaries. This is why I like the graphing, right? When you're drawing the graphs, you have to put the boundaries on, because if you don't mention the boundaries, you won't get any credit for these whatsoever. So just wanted to show you that. I'm not a huge fan. I tend to wait to tell people about it, but I thought it might be good so you can check your work right now.